Good morning, guys. This is our last lecture. We actually reached the end of the semester, and we have covered everything in Chapter 8. So now I just want to show you a couple of examples as our last lecture this semester. So let me share my desktop. Okay, so we talked about the C strings and how do we manipulate C strings and what's the important thing about C string. So one thing that you might see in your code, let's say in this example we are reading from a file, reading contents from a file, and then we're writing the contents to a file. So as we're reading the contents from the file, we're reading it into a character array. Now a simple character array is not a C string, right? So when we are done processing the character array, we can just use the stream extraction operator and then send the character array to the file. So let's see what that looks like. Okay, so if we have the input and the output file, and let's see if we run this, or let me comment this out and so we can talk about that. Okay. So I need to go to my file system, and oops, where's my file system? Okay. So this is my input file, and then we look at the output file, and you can see some strange things going on right here. So why do we get this garbage at the end of our file? Well, if we go back to our IDE, what we might want to do is basically break the code before we write the data onto the file. And let's see what this array looks like. Okay, so you can see this is an array, what it looks like in Visual Studio. Okay. Let's see. I'm trying to see if we can get to the raw array right here. But we cannot. So the main thing what I wanted to show you is you can see that there is no /0 at the end. Right? So if there's no /0 at the end, this is just a character array. But it's not really a C string. And when we look at the output file, need to click complete. Okay. So you can see the garbage at the end. When you see those I with an apostrophe on top of it, you know that those are the default, the negative 52, the default characters. So you know that those are default characters that were really not initialized. So what you can see is this really seems like what the extraction operator is doing. It takes this character array and turns it into a string, where we know the string has more character placement than actual characters. And that's how it turns it into a character string, and then it places it into the file. So because we don't know where the string ends, where the character array ends, right? That's the difference between a character array and a C string. The C string does have a terminating null character. So what we can do is we can force that null character into our character array, and after we force that /0, the null character, okay, then we look at it. Okay. So if we force that null character, when the string extraction operator will try to write that character array to the file, now it is in a format of a C string, so it can write the C string, because now the C string we know where it terminates. So when we play this through, and then we go to our output file, okay, you can see that the output file now does not have that garbage at the end of it, so you can actually restrict that. So we're using our knowledge of C string in order to find out what went wrong and how to fix it. So we fix it by forcing the /0, or the null character, at the end of the character array. So let's see what else we can talk about. Now you had a homework assignment. Remember when you had an integer, and we used arithmetics to basically split the integer into its digits, and our goal was to add the digits together. So now, because we know arrays, we can actually use the arrays in order to process that. And in this case, we can really look at the number as a string. And because we know the string is a collection of characters, we can look at each one of the characters as an integer. Now each one of the characters, and you can also do some validation, okay? The reason that we take 48 out of the array is because we want to start at 0. Now the character 0's ASCII value is 48. So if we take away 48 from 48, we get 0, but now that's going to be an integer 0. So that way we can process the actual string one character at a time and turn each character into a digit, and then just sum the digits in order to find the sum of the digits. Now in this case, I also sent and did the processing in a function. Now the function, as you can see from the prototype, I sent the string. String is the actual number that the user will type in, and that string, even though we know the string contains a C string character array, the string we have to send to the function, the ampersand, so it's still going to be by reference, we're sending it by reference. We do have to specify the ampersand. Now, when we are passing an identifier, an array to the function, if the array is one-dimensional, we do not need to send the size of the array. But if it's multi-dimensional array, then we have to send the second and subsequent sizes of the array to the function. So that's why in this case you can see that in the prototype and in the function's formal parameter list, I'm specifying the size of the second array element. And then you just go through the actual string, one character at a time, stopping when you are reaching the end of the string. And at that point, you have, in this case, I have a two-dimensional array. So in the two-dimensional array, what I really have is an array with two columns. Okay? So this is an integer array, right? So you can see that it is an integer array. It's an integer data type. Okay? And we have the rows, and then we have the columns. Okay. So the size is 2. The size is referring to the columns. So the columns are going to be 0 and 1, and then we're going to have the rows. Okay. But that's how it looks like. So as you can see, when I'm filling the actual array the first time, right? So you can see that what you do, if let's say you typed in 1, 2, 3, 4, then you are filling into column 0, and you are incrementing I. So incrementing I increments the row, but still keeps the column 0. So that means you are typing in, let's say 1, 2, 3, 4, 5, and 6. Okay? But if you look at the second loop, right, in this case the second loop, now here we are looking at initializing j to the end of the array, and then because the dash dash, what we're doing is we're going backwards. Okay, so where does j start from? J is starting from the length of the array, and it's going backwards. Okay, and I'm copying whatever is in the string array into this array going backwards, right? So what we're doing is 1, 2, 3, 4, 5, and 6. Okay, this is just a little twist on this, just so we can see it, just we can have a basic idea what we can do. But the main thing is you need to understand what is it that you're processing. In this case, is a string. The string contains a C string The C string is a null-terminated character string. The character string can be processed one character at a time, and we need to understand how do we store the character or the elements into an array. We can fill it from index 0 going in an incremental fashion, or we can start at the highest index element in the array and go backwards. And then we can process it, okay, any which way we like. So the main thing here is to see the two-dimensional array is passed. We do not have to use the %, but we're still going to passing this into the array, into the function as an array reference. So if our concern might be that maybe the function will be changing the array itself, then what we can do is we can make the array constant, so that way, even though it's a reference, we are not allowing the function to actually make the changes, make any changes to the array itself. Now in this case, this is not our goal, because our goal is for this function to fill the array with the elements that's coming from the string itself. So that is really not what this would not work, because our goal is to actually make changes to it. Okay? So in this particular example, here we are talking about, again, the whole concept of C string. Okay? And in this case, we are looking at processing a dynamically generated file name. So let's see, where are we? Okay. So you can see that when we are asking the user, okay, so this is kind of like what you have in your final project when you processing the cable customers, the cable company customers, and then you're going to ask the customer if the customer would like to have a receipt printed. If the customer says yes, then you can ask the customer to input the file name. Now if you input the file name and you read it as a string, right, because it looks like it is a string, then what we can do is we can extract the C string out of the string itself, and that way we can open up the file. Okay. Again, so if the string has too many elements, too many values, you might get garbage at the end of the actual character list. So this way, if we extract the C string out of the string, then we ensure that we only considering the actual characters that belongs to the string, and not all the character placeholders. So now with the string itself, the string data type, we do have an option to extract the string, the C string. So what if the customer types in a file name that has a space in the file name? Now if we have a space in the file name, what we can do is create a character array. And when we created a character array, now we need to make sure that we're telling the user what is the maximum amount of character we can handle as far as the file name is concerned, right? So in that case, you can see that if you have a character array of 21 characters, you have to make sure that you read one less character. Now in this case, why are we using getLine? Well, we're using getLine because getLine will also process the space in the file name. But we want to make sure that it's actually going to read only 20 characters. Why? Because the 21st character is going to be the /0, which is the null character. Okay? So reading into a character array, you need to still understand what C-string is, and then make sure that you leave room. You don't have to force it, you don't need to add it like we added before, but you do have to account for that extra /0. Okay? Otherwise, again, if we, let's say the user, let's say you have an array of 20 characters. Let's go something slower, smaller. Let's say it's 5 characters. And we're going to read in 5 characters. Okay? And in this case, okay, we have an array, 1, 2, 3, 4, 5 characters, and the user is going to type in let's say ab.text. So that's going to be the output file. That's what the user would like to have as an output file. Now what's going to happen? Well, we're only going to read 5 characters, right? So if we read 5 characters, it's going to be A, B, dot, T. Okay, so we have the dot and then the T, and then we have to specify the /0. Okay, now if we don't specify the /0, okay, if that's not going to happen, then we're going to store 5 characters, and in that case, it's going to be ab.tx, and then what follows after tx, we don't know. Okay. Now, if you're lucky and you get the t in memory with a /0, then it might work, or sometime it might not. Okay. So that's why we say that you need to make sure that you're handling that, and you have a file name or an array for the file name specified, and then you take only the characters and you ask the user for the number of characters that would accommodate that extra /0. Okay, and that's why because these two numbers relate to each other, and we can even talk about this number right here that also relates to the message. Okay, it is much better if we would do something like const int, let's say file name size, and we would say 20. Okay, and here we would let's do 21. So we have fn size. Here, instead of saying 20, we would say file name size -1. And then when we actually printing out the message, okay, let's break this message into two parts, and then type in file name size -1. Okay, so why would you do that? Why would this be a better code if we writing it this way? Well, let's see what happens if I change this to, let's say, 5. Okay, so when I change that to 5, then we have an array of 5. We are automatically telling the user that I'm expecting you to give me 4 characters, and when we're reading the characters, we are automatically reading just 4 characters. So we are automatically adjusting to that extra null character. We don't have to worry about any kind of shift between numbers or keep track of what or how many places we need to update the code. One update of the code, say 45, right? And all the rest of the code adjusts to that, so we don't have any kind of a problem. So this is just to avoid any kind of a human error. It's much better to work with constant values. And then you can look at multidimensional arrays, right? And with multidimensional arrays, you might have to look at arrays from a point of view. Let's go to the IDE. It might be better to see. Okay. So with multidimensional arrays, okay, again, use constants, right? So with the constants, it's going to be much easier to adjust the array. If you are filling the array with constant values or initializing the value with a specific number list, see, it's much better to list, let's say, the 2-dimensional array like this, because the array will look exactly like that. Okay, so when we do have an array, and this array going to have number of rows and number of columns, so the row going to be 5. So you can see here, it's easy to see row number 1, 2, 3, 4, and 5, and then each element or each row has 4 columns, and you can see if we align these numbers, remember the spaces don't count in C++, so we can put in the spaces and really write the code this way, and it's much easier to see what the 2-dimensional element is supposed to look like. So again, use the constant values to identify what is it that you're really talking about. Okay. So when we are processing arrays, right, so we can process the array by column, or we can process the array by rows. Okay. Now here in this particular code, this is the most important line of code right here when I'm using an output manipulator. And this output manipulator will actually show the specific column by setting the width of the output to a specific width, where we multiply it by 4, and the multiplication by 4 tells us which column to actually print out. So yeah, we can run this and see if it makes more sense that way. Okay, so you see, I'm trying to print out column 3, so the numbers show up under column 3. Now, what if I want to print out column 2? Okay, so if we are printing something out, column 2, you can see it shows up under column 2. Okay, now why is that? That's because every single one of these columns are printed out in 4 character spaces. Okay, so because of the 4 character spaces, if I'm on the 3rd column, right, that's going to be 3 times 12. So 3 times 12, 12 character space is the space when I'm printing the value in. So it looks like I'm printing the third column. Okay, so sometimes you might have to look at the output and look at the algorithm of the output, because now the actual single line of code adjusts to whatever column that I'm printing out, because the columns are evenly spaced. So whatever column I'm referring to, it is a multiples of 4. Okay. So again, it is kind of like a design. It's not just printing out the column, but think about what is the nicer way of printing out the column. Because you can say that the third column is, now here's the list, and you can just print it out horizontally. But from a user point of view, it's not a nice output. So this way, it's much nicer. Even with this, kind of like the index values are printed out, right? So you can see here, I'm really focusing on making sure that it makes sense to the user what I'm trying to say here. So it looks like this is my table, and within the table I have the index values printed out for each one of the columns, and I underline it to separate it, that those are not values, those are just labels. Okay, and on the left hand side I'm printing out each one of the row index values, separating with a colon. And then when I'm printing out the actual values, I'm printing out the values corresponding to the actual column. So again, you're looking at formatted output that makes sense to the user, and not just getting it done, throwing it on the screen, and let the user figure out what is it that you're trying to say. Okay, so at this point, just be more user-friendly with your code, and try to think about not just from the computer science point of view, but also from the user point of view. Okay, so in this case, we received in the function the two-dimensional array and the column that we're going to have to actually print out. And the column was hard-coded, but the row was stacked in order to process the whole array. So the column was not incremented because this was supposedly processing the array by a specific column. So the by row is going to be doing the same thing, but we are receiving the row identification. So that means we need to stack the column. So the row stays the same. So the first index within the two-dimensional array stays constant in this case, and the column will actually change. So that will create that horizontal processing. And just the print function. Now in this case we need a nested for loop, because in the nested for loop we need to process the row, and then within each row we need to process each one of the columns before we go to the next row. So that's an important example. This is a really simple example to show you how two-dimensional arrays work. Okay. So what about another example that I just saw? Basically, I just saw that on the internet today, and I just wanted to see if we can use our knowledge to come up with something fun based on this chapter. Okay. So let's say here's an elf name list, and people likes to play with this kind of concepts. Now, when you look at this, you can see that this is just two lists, right? So the two lists is when you have 26 characters. So we're going to ask for the user's first name, and based on that, you have one list. Now, what kind of list is that? Now, that list looks like it's a string array. Okay, and then we have another string array where you're asking the person for the birth month, and then you associate the birth month with a particular string, basically, right? So it looks like two strings, two individual string arrays, and maybe we can come up with some fun concatenation of two strings based on the selection by the user, right? So how would we go about solving something like this? And in this case, just come up with random strings for the arrays. So here you can see I have a single string array, okay, with 26 items, okay, for the 26 letters. And another string array where I have 12 items or 12 strings for each corresponding to each one of the months. Okay. So then basically whatever name a user picks and whatever month the user picks, then we can generate some fun concatenated string. Okay. So then we are asking the user to enter the first character, or they can enter the first name if they want to. But what is it that we're going to do? We're basically going to read the first character, right? So when we use cin.get, if the user type in Richland, because of the .get, we're only going to read the R, the first character. So that way we don't have to really annoy the user asking them for the first initial. But if we do ask for the first initial, then they have a choice. They will just type in the first character, or if they do type in the full name, we're still going to read the first character. And after that, just to make sure that we're not going to have the rest of the characters in the input buffer, we can just ignore the rest of the string. And then we are reading their month of birth, right? So basically we have to have two arrays, and the two arrays, one of them going to hold the string array based on their first initial, and another array will hold the strings based on their birth month. So we need two questions and two variables. So one variable, and then we have the other variable. So we have the initial and we have the month. Now when I'm reading the initial for the name, it might be uppercase or lowercase. So just to make my life easier, instead of dealing with uppercase, lowercase, I right away convert it to uppercase. So when we have the uppercase, now what am I doing here? Okay, you can see that in this case, whatever the uppercase character is. Okay, let's say the uppercase character of their first name's first initial is A. There's going to be A minus A, which is going to be 0, right? So if it's 0, then it is the first element in my array. Now I made it a little bit more complicated than it has to be, because I'm also generating random number, right? So random number, so 0 plus 1 is 1, and generating a random number basically on that 1, well, it's going to be 0. So it doesn't really make much sense if the first initial is A. But let's say, what if the first initial is C? Now with the first initial C, C minus A is going to be 2, right? So A minus A is 0, B minus A is 1, C minus A is 2. So the random number I'm generating is 2 plus 1, which is 3. Whatever random number I generate, I mod it with 3. I'm going to have a possible index values of 0, 1, and 2. So I have 3 names to choose from that I'm going to choose randomly. So it's not even, I think it's more fun. So it's not like we had it in the example when everything is hard-coded, right? Each character, the name or the string is hard-coded. We can do that, and it's even simpler code. But just to show you that we can, based on user response, we can still randomize things. So you can see that randomly, based on the user response, we're going to pick a name from the names array, and then based on the user's birth month, we're going to again randomly generate an index value for the months array, and we're going to randomly pick a string from that array as well. We're going to concatenate the two by displaying it on the screen, and the user is going to see this strange name. Now the second example here, what I did, I actually realized, and you can see that we have 2 string arrays, 2 individual string arrays. So why do we need a 2 individual string array when we can create 1 string array of 2 dimensions? Right. So in this case, what I'm doing right here is generating a string array with 2 columns, right? Where one of the columns going to have 26 elements, the other column only going to have 12 elements. The rest of them just going to be non-strings. Okay. But this way we can process the 2-dimensional array. So here you can see that I'm going into the options, okay, and the options is my 2-dimensional array, and within the options, again, I'm generating a random first index value. In what column? Well, now instead of saying 0 and 1, I like to say that the first column is going to be the names, and the second column is going to respond to the month. So instead of saying 0 and 1, what I decided is to create an anonymous enumeration type. And you can see in the anonymous enumeration type, names is going to be 0 and month is going to be 1. So it's easier to read right here that you can see that basically randomly generated row in the columns, in the names column, and then again randomly generated row in the month column. So we're doing the same thing, but now instead of 2 separate string arrays, we are using 1 2-dimensional string array. And the third example, what I'm trying to do is read from the file. And if you look at our input file, it just has a bunch of names. Okay. I grouped them. It doesn't need to be grouped this way, right? But basically I have 26 rows over here, and these separated by space, the second string that is going to be 12 strings corresponding to the month. Okay, so I'm structuring the input also with 2 columns, and then the single column for the rest of the 26 characters for the names array. Okay. But basically what we have a file, okay? And when we are reading from the file, what we're trying to do is, so this is where we process the file, okay? So how do we process it? We have 26 rows. So I don't have to worry about the size of the array or how big the array is going to be, right? So we have 26 rows. And I know that I'm going to fill up the 0th column, I'm going to fill up totally with string values. Now because the second column only going to have partially filled strings in it, okay, that's why I'm looking at, and you can see why I have this row less than 12. So up to the 12th entry, right? Up to the 12th entry, I want to keep writing across column 0 and column 1, column 0, column 1. When I'm done with my 12 month values, at that point I switch over and we only copying values into the first column. So we only need to keep writing over here to finish up the first column values. So that's why I have the selection statement in the for loop. But at that point, it works exactly the same. So we have a two-dimensional array, just like the options array. So we're going to end up with the same array, but at this point, we process the elements from a file. So now, if we compile this and you want to give it to somebody, that somebody can create their own input file and change the names and have a fun concatenated name generated. Okay, so let's just run this and see how that works. Okay. Oops, I'm not looking. I need to go and change the source code. There we go. Okay, so enter your initial and then pick a month, and then you can see that each one of these words really concatenated by randomly selecting words from the two arrays or the two columns of the two-dimensional array. And this way you can have this really fun applications created, and all this is because somebody showed me this little fun exercise or fun picture from the internet. Okay, so that's pretty much it. That's all I wanted to show you guys. Start thinking about how do you use the knowledge that you learned in this class. Okay, you can go back into previous assignments or look at the example code that came with your book and see if you can restructure it, if you can modify the code, make it something fun, and keep using your knowledge. So don't forget C++. Okay, it's going to be a really useful skill set as you're moving forward with your degree plan. Okay, so have fun, have a great break, and hopefully I see you on campus one day. Bye.